So if I take my calculator, second tangent, 3 divided by 4, and I get 36.87. So this angle is 36.87 degrees. And I'm done with that one. Okay. I want to do one of the other ones where they're not tip to toe, just to show you how those work. So again, at the top, here are the two main things you need to know. The magnitude is always equal to the square root of x squared plus y squared, and the angle is always equal to the inverse tangent of y over x. Okay. So let's do 9 because it's such a neat one. Okay, now if you notice 9 actually is lined up toe to tip, toe to tip, toe to tip. So all the vectors go around. So the resulting vector for this one is actually just from the beginning of the first one to the end of the last one. So if I change this to coordinates, it's over 2, left 2, and up 1, 2, 3. And again, if I don't want to do that, I can change all the vectors. So in this case, 1, 2, 3, 4 of them into vector notation and add them. So just to show you it works. The first one's 0, 4. The second one is 2, 0. The third one is left 1, down 1. So negative 1, negative 2. And the last one is left 1, 2, 3, up 1. And if I add those all together, and I didn't make any mistakes, I should get negative 2, yay, and also 2 plus 1 is 3. So notice I get the same answer. Okay. Now, so the magnitude for that red vector, the resulting vector, is going to be the Pythagorean theorem. So it's going to be the square root of 2 squared plus 3 squared, and you can put that in your calculator. And the angle is going to be the inverse tangent of the y value over the x value. Okay. Now, one thing I would do is I want to check that one because sometimes there's always two angles that'll have the same tangent. So let me draw what I think would be the angle. So here would be my 0 degree line, and I'm trying to find this angle right here. And obviously it's going to be a little more than 90 and a little less than 180. So I'm not going to do the magnitude, but I do want to do the tangent just to check something. So the inverse tangent of 3 divided by negative 2. Oh, I'm sorry, I didn't hit inverse tangent. Inverse tangent of 3 divided by negative 2. Okay, so I get negative 56.31 degrees. Angle is about negative 56.31 degrees. Now, here's one little thing that you might have to fix on some of these. Not often, but sometimes you have to do that. If I draw this angle, it's actually in the down direction. It's actually going to be over here, going in the totally opposite direction than my vector. So this actually is the negative 56.31 degrees, which is 180 degrees off from what I want. So if you ever notice that happens, and you can eyeball it, it's not going to be like it's really close. It's going to be 180 degrees off with what you're expecting. All you have to do is take your answer and add 180 to it. And my actual answer is 123.7, and that's a lot more what I was expecting. So my actual answer is 123.69. And let me show you why that happens. It happens because there's actually two angles that have the same tangent in 360 degrees. If I do the tangent of 10, I'll get the same answer as if I add 180 and I do the tangent of 190. Well, when I ask my calculator to do the opposite of that, and I ask, well, what angle produces this tangent? It's only going to give me one of those. So if I get the wrong one, I just add 180 to it, and that will be the right one. So for some of these, if it seems 180 degrees off, add 180, and that'll be your angle. Okay, so I want to move on, and I want to do some from the third page, just one or two. This one, actually, now they give us the vectors in that direction magnitude stuff, so we're going to have to change it, add it, and then change it back. Okay, so one of the things I just like to do, you don't have to do this, is actually draw a picture of what about my vector is going to be. So if I pick up one vector and add it to the end of the other vector, my resulting vector is going to be about this red one, right? So now what I'm going to do is I'm going to take each vector and change it to XY notation. So I'm going to change vector A, and I'm going to change vector B. So the first one, the magnitude's 50 and the angle's 30. So remember, I'll write at the top, x is equal to the magnitude times the cosine of the angle, and y is equal to the magnitude times the sine of the angle. So for the first one, it's going to be 50 times the cosine of 30, and 50 times the sine of 30. Now those are ones that we can do ourselves, but for most of these, just go ahead and put them in your calculator because we're going to get rounded answers anyways. So I'm going to do 50 cosine of 30. So I get about 43.30. And the only thing I have to do is do the same thing, 50 sine of 30. And that's 25, which is kind of expected. If you think about your 30, 60, 90 triangles, it should be half the hypotenuse, but again, so 25. So there's the one. Now for the second one, it's got 70 is the magnitude, and the degrees is also 70. So for this one, it's going to be 70 cosine of 70 and 70 sine of 70. Okay, so I'm going to do 70 cosine of 70, which is 23.91. And then I'm also going to do 70 sine of 70. And then go back to my calculator. And for the second one, I'm going to do 70. So I get 65.78. 65.78. Okay. So my next step is to take these two vectors and add them together. So for the x's, work my way backwards. I get a 1 and a 2.67, and then 6, so 67.21. And then for the other one, I'm just adding 25, so 90.78. Okay. Now, I can't leave my vector like that. That's the resulting vector, but I do need to change it back to the direction and the magnitude. So again, the magnitude is going to be the square root of 67.21 squared plus 90.78 squared. So second square root 67.21 squared plus 90, oh wait, it's squaring it twice, clear. 67.21 squared plus 90.78 squared. 112.95, so that's going to be the magnitude of this thing. And then the angle is going to be the inverse tangent of the y, which is 90.78, divided by the x, which is 67.21. And again, every time I do that inverse tangent, I'm just going to make sure I get the right angle. So second tangent of 90.78 divided by 67.21. So 53.48. And if I look at my picture, it does look to be about that. So now I'm going to write my final answer. These both are in newtons, so the final force on this object is 112.95 newtons at 53.48 degrees. So again, for each one of these ones at the bottom, you can do the same thing. Use the magnitude cosine of the angle, magnitude sine of angle to change x, y, add them together, and then change them back using the Pythagorean theorem and the inverse tangent. Okay. So the last page kind of combines everything. And this is the one we did a lot on the third day that we did vectors. Okay. So suppose a hiker walks 4.5 kilometers in one direction, and then he turns 45 degrees to the right, and he walks another 6.4 kilometers. What's the magnitude of her displacement? Now, they don't tell us what direction she starts off with, so to make my life easier, I'm going to start her off as going east. Because then it'll be 0 degrees, the direction she originally starts. So here's her initial vector, 4.5. And you don't need to do that. Some people like to make them to go north and work from there, and it's fine, it doesn't matter. Now, imagine you're at the tip of that point and you're facing the arrow, and now you're going to turn 45 degrees to the right. So what's going to happen is you're going to turn this way, and this angle right here is going to be 45 degrees. And you're going to walk another 6.4 kilometers. So my resulting vector, they are tip to toe, so I can add them, is going to be this. At the tip there. It's a little off. So I can't just use the Pythagorean theorem on this because it's not a right triangle. But what I can do is change both of those vectors to xy notation, add them, and then change it back. So for the first ones, it's really easy because it's 4.5 to the right. So the coordinate for this one is going to be 4.5, comma 0. Now for the second one, here's where we have to do a little work. It's going to be the angle. Now I'm going to use the whole angle because if I use the whole angle, not only will it give me the x and the y, but it'll also be with the right degrees. So what I'm going to do is I'm going to say this is negative 45 degrees, right? Because I'm going down. And if I use the negative 45, not only will I get the right numbers for x and y, I'll also get the right sign. So it's your choice. You can either use 45 degrees and fix your signs, or you can use negative 45 and have it give you the signs. Okay, so I'm going to do 6.4 times the cosine of negative 45, which is 4.5253, 4.53. Now, it's a 45, 45, 90 triangle, just that one vector, just that part. So I expect I'm going to get the same number, and I will, but it'll just be the negative. So if I do 6.4 times the sine of negative 45, I get negative 4.53. Which is kind of nice, because if you take a look at this x coordinate and this y coordinate, you can see that the x and the y, x is positive, but y is negative. So it's kind of nice if I use the negative 45. So now I add them. So I get 9.03 and negative 4.53. So the magnitude is going to be the Pythagorean theorem on these. So second square root 9.03 squared